So we just talked about what CSI is not. The next question is, well, what is CSI? And you can boil it down to three simple interfaces. If you're familiar with the Kubernetes volume plugin interface, these operations are going to look very similar. You have create and delete volume. You have attach and detach volume to a node. And then finally, mount and unmount a volume from a node. Very, very simple. The purpose is pretty clear to, I think, everybody in this room. What's that?
List volume.
List volumes is part of the spec, but the core that we cared about were those three. This is where we started. And then folks started asking about, well, what about snapshots and replication and all these other potential features? And the answer with CSI is it's not intended to be the cutting edge. It's trying to be an appliance. It's trying to say, what are the things that we all agree on? Let's put that into this interface as a standard. And then as we experiment and add new features, we can consider pulling them into CSI. So for the 1.0 implementation, snapshots and other extra features are not going to be part of that. So between these three sets of calls, it's important to note which set of calls can be called from where. Both the create volume and the attach volume calls technically can be executed from anywhere within the cluster against some sort of storage control plane to create the volume and then have it make it available to a particular node. That final step of mounting the volume to a particular location on the machine to make it available inside the container is the step that can only be executed on the host machine where the workload is scheduled. And so if you look at the way the CSI spec is broken up, it's broken up into three services. One is the controller service, one is the node service, and then the third we're calling identity. The controller service are the set of methods that can be executed from anywhere on the cluster. The operations in the node service are guaranteed to only be called from the node machines themselves. And then finally, identity are a set of operations which are common regardless of the service. All right, so let's talk about naming next because that's going to get confusing. So create volume, delete volume, attach, detach, mount, unmount, very nice, easy volumes. That is not at all what we call them. Yeah. Attach and detach have been renamed to controller publish volume and controller unpublish volume. And mount and unmount are node publish and node unpublish. The reason for this was that the argument was made that for each one of these operations, for example, attach, you could do more than just attach, or for the mount actually is a much better argument. Mount is not necessarily just a mount operation. It could be a set of operations, including formatting and basically everything that must be executed on the node machine to the last mile to make the volume available. And so these names are an attempt to make it generic enough that it doesn't anger anybody. So now let's walk through the user flow. For folks who are familiar with the Kubernetes storage API, this is going to be very similar. You have a user who demands 20 gigabytes of storage, and our master control plane reaches out to the controller and issues a create volume call against the CSI volume plugin. It passes in name, capacity, and the capabilities of the volume, including the requested disk space, and finally a set of opaque parameters which matches up with what we have in storage class today. And then the plugin can go ahead and talk to the storage control plane to create the volume. It returns a success or failure. All these API calls are synchronous. They block until they're complete. There was a big debate on whether they should be synchronous or asynchronous. We decided for the sake of simplicity that we're going to keep them sync. Folks who were arguing for async realized after some debate that what they really wanted was to ensure that these calls are idempotent. And idempotency can be implemented over async or sync, it doesn't matter. And we decided, because we wanted to keep the interface dead simple, that we're going to make sure that all these calls are blocking synchronous calls. Underneath the covers, the volume plugin it can implement them however they want. So if the backend calls are async, you just wrap it in a synchronous call. The volume plugin then returns a standard volume info object, which contains information about the volume that was created, including the capacity, access mode, and additional metadata about that volume. And then the user schedules a workload referencing that volume somewhere on their cluster, and the control plane calls out the controller publish volume call against CSI to make sure that the volume that's referenced by that workload is available on the node that the workload is scheduled to. So for this particular call, the identifying information about the volume is passed in along with the node that it should be attached to. And this returns opaque information saying it succeeded, and maybe things like this is where the volume is actually mounted, or where the device is available. Basically, information that's opaque to the cluster orchestrator. That information is then passed in on the subsequent mount call. So on the node itself, Cubelet in this case will reach out and call node publish volume with the same set of information, the volume handle, a target path where the volume should be mounted, and the publish volume info, which was returned from the previous call. And that's pretty much it. So if you squint, it looks pretty much like the Kubernetes API. There are other calls that were added to CSI, like list volumes, which Steve mentioned. I'm not going to go into details of those here. You can read the spec if you're interested, or grab me offline. So that's kind of the high level of what the spec looks like. Now let's talk about how we're going to expose this in Kubernetes. Yes. Please.
So I'm assuming there's buy-in from the other COs,
yes.
Swarm and Mesos.
Yes.
The language seems very Kubernetes native.
Yes. No, this is.
Doesn't have controller, or Swarm doesn't have controller. So
yeah. So Docker Swarm, Mesos, Cloud Foundry are all okay with the language and what the spec currently looks like.
Kubernetes had the benefit of being a little bit later than the other. And so the nomenclature is kind of down there. It worked out well.
Yeah, but just some, so Saad and all these others have been working, storage working group, a series of calls where they get together, discuss this. That's been going on for months now.
It actually predated the CMCF working group by like 6 months. So these people have been in rooms. It's been very peaceable, very amicable.
Like this is even predated the CMCF storage working group for about 6 months. So these people have been working together, just engineers in a room. It's been very amicable, very, very even-handed. So I don't think Kubernetes has been beating people over the head and saying use our nomenclature. It's worked out really well. And now it's formalized in the CMCF working group, which is great.
I was putting on my Swarm hat saying if I was on the Swarm side of the house, I would be like, oh, if I want to implement all of this, what do I need to do? Just because.
Yeah.
I think Luis had a question.
Yeah, I don't know if you want to spend time now, but I have the question about the slide you had on the snapshots and replicas. And I know I'm bringing in it was in the bottom of the list. But so yeah. So what I'm trying to think about is the situation that could happen that storage vendors start creating CSI plugins, and then snapshot support comes in.
Yep.
So what do I do as a storage vendor, right?
So here's what I foresee. Starting off, CSI is going to be alpha. It's not going to be the front seat. But as soon as it becomes stable, which I imagine is going to be in a couple of quarters, 2 to 3 quarters, then CSI is going to be the primary mechanism by which we expose storage through Kubernetes. And then any new features that get added, we're going to have to think very hard about how that gets into CSI.
It's important to remember, no one's saying that snapshots don't work in your storage system. People are using snapshots now and have been since before Kubernetes came, and even once Kubernetes came in Kubernetes environments. It's all just basically the centralized management and which users in Kubernetes have access to them. And right now, I mean, what we, a lot of the basic, the initial goals of getting these plugins to work, I think, were cross-orchestration compatibility. So let's say you have all of your storage in a Docker system and you want to move to Kubernetes or vice versa. That'll be a fairly simple process. And the other one is that making sure that there's a way for plugin providers to have a stable system to integrate with Kubernetes without having to write entry plugins that mean you've got 3 or 4 people who can review them. And then the only way you can get fixes in is waiting for either a weekly or quarterly update. Those sort of felt like the highest priority items to solve. And snapshots themselves do introduce a whole bunch of complexity that need to be dealt with later. We all understand that snapshots is dear to many of the vendors, but just getting the base pieces together is going to take a while. And so we thought we would get that done first. I'm not sure it precludes the ability to use snapshots. And if it does, we should talk about it when we get to it.
Thank you. But what I mean is, as a storage vendor, you have to put time and effort into creating a CSI plugin and being able to QA it and so on. If there's a specific call that is only for Kubernetes, then that creates issues. Because how do you implement that? That's not part of the CSI atomic. So
we're not suggesting that. Though.
no, I'm just bringing that up because it's not part of the spec right now. That's all.
Yeah.
But I agree.
Yeah. So I think that's so I'm usually
the person that hates specs and always think that they're kind of silly. But in this case, I've come to the conclusion that I'm doing work on Swarm, Mesos, Kubernetes, everything else, OpenStack, and it sucks, right? So we have to solve this problem. My biggest concern is, I think everybody's kind of agreed on going this route, and I think it's a good route. I think the spec looks great. It's coming together good. One thing that I'd like to see is everybody actually being a little more consistent and proactive in driving this. Honestly, I think 2 to 3 quarters is too long.
Yeah.
Frankly, I think it's way too long because you're going to continue to have fragmentation like you have today, and it's going to be a mess. None of us are going to be any good, basically. So
I think we all think it's too long too, but I think we're also, unfortunately, right now limited a bit by the release train of Kubernetes itself and the way we go from alpha, beta to stable.
So that's completely fair, and I get that. I don't have a problem with that. What I do have a problem with right now is the fragmentation in where the development efforts are going. So whether that's flex volume, external plugins, cloud plugins, or CSI, I think that actually creates more difficulty, not only for us as developers, but also for the consumers.
Yes.
I think we all agree.
Yeah, this is a classic problem of the cool, shiny thing that we all want is always a little bit out there, and the thing that we don't want to use is being deprecated, and we just kind of have to deal with it and do the best that we can. I'm hoping to get an alpha implementation of CSI out this quarter, so folks who are ambitious could theoretically start implementing CSI volume plugins that work with Kubernetes in Q1 of next year. Theoretically, but for everybody else, it does take time. Like Michael said, we're tied to the release cadence of Kubernetes itself and going through the alpha, beta, and stable process.
It feels like storage vendors will be back to the old game of saying that CSI has a certain set. So let's do one CSI and test it for all the environments. But for the new feature, latency guarantees to the CSI, nobody can give you those.
Yeah.
So I have to maintain an ecosystem where like I have like the new snapshot feature for Kubernetes separately from the Docker one. So vendors don't have, it's market timing versus Kubernetes timing.
Yes. It is. I look to Steve and Brad, who've been doing this longer than I have. I think that the success of Kubernetes and the interest of it took all of us a little bit by surprise. Generally, when you see other systems become as widely used and interested by the communities, both traditional enterprises and open source folks, there's usually a much longer duration of time for things to cook. I think before we got this much interest in Linux, it was like a decade or something. Kubernetes is, I hate to use the term, we're being filmed or no?
Yes.
All right, well, I'll use the term. Sometimes it's a little bit of a success disaster. It's so successful that it's, we're running on ice a little bit. And, this is a bit where we are. I think the nice thing now, due to the work of so many people in this SIG, is that we have a path. It's great to hear that we have a path that people like. It's just that we all want it now. And so the goal is to focus on getting through that path as soon as possible.
So the challenge there is no amount of open source contributions will speed this up, because it's a discussion between the container orchestrators. The CSI spec itself has like time things that I don't know how we can help speed it up, even by adding more people.
I don't know if I would say that you can't speed things up in some of these areas, but I think the big thing is one of the successes of Kubernetes, I think, and if I wish Tim was here because he drills this in my head quite a bit, is getting the APIs right and taking the time to cook them so that they really are future-proof. And if you look at networking, there were some things that were done in a pinch that we really regret now. If you want to have fun, listen to Brian Grant talk about services and ingress, and why things that we kind of did to get out the door. We know how important these interfaces are, and we do want to get them right. And so that's why we are going through the normal processes as we do now, and this has actually served very well in other areas. And yeah, it does hurt, and that it does mean that all of us, because we're vendors too, have to deal with the fact that certain portions of the CSI are going to be nailed down, and then other ones are a bit more mutable over time. I'm glad that we're all here in the face-to-face and we can share the frustration. But at the same point, people have been working on this quite heavily. There's a lot of investment. If you feel that, there are areas that you want to go faster outside of the cooking and baking part of getting it through the release, that's great. But I also don't want to, I worry about the Mythical Man Month. We have how many people working on the implementation of CSI right now?
At least
in
4
Kubernetes?
of us.
So there's 4 people from how many companies?
4 different companies.
So 4 folks from 4 different companies. I don't know. I'm again looking at Steve and Brad, who may be a little closer to me on this. I don't know if adding another 2 or 3 developers will make it go faster. If it would, I think we've told everyone working on it, holler, because we know that there's a ton of great people who can get involved and accelerate the process. We all want to be behind this.
So what's the other cloud provider story? I mean, who's doing the Mesos CSI implementation?
It's actually G, and he is on the line.
He's supposed to be here.
He's on the VC. Do you have any specific questions for
Well,
him?
because I expect that as we do the Kubernetes CSI implementation, we'll iterate on the specs some, right? So we'll never have it fully nailed down until we actually have an implementation of proof
And
of
that's the plan.
concept. And the thing that'll make it move faster is if other cloud providers start doing proof of concepts now.
Yeah,
Say, hey, this
and they
doesn't
are.
work, or this does work.
They have already started.
Okay,
Yeah.
so we're moving as fast as I think that we
Yep.
could.
And the other side is the plugins, we have a spot to talk about that. Like on the receiving side, we've done a ton of work there to make sure the spec actually works as well. So I think all sides that are validated right now.
Do we have any information about when other COs may support CSI?
I don't have their exact timelines. G, do you have any updates on when CSI would be available to Mesos users?
Yeah. So can you guys hear me?
Yes.
So Mesos soon support CSI in the next release, which is 1.5.
What about Docker?
I don't know about Docker. Nobody from Docker is on the line. Yeah.
I am, just to set expectations one more time and hopefully not rattle on this and talk more on the technical areas. I mean, has anyone here worked with the IETF and watched those standards go by too? So I guess there's a part of me that says, I don't want to paint the IETF as, a bad actor. I think they work really hard and they've got a very difficult job. but this doesn't seem unprecedented either. It just seems that we all want to get through it really fast.
So, so that goes back to my point. Standards, kind of, I was on the ice. Definitely it's not on this one. But my point is, what we're doing today as vendors, developers, and stuff like that doesn't work. And this is a good way.
Right. I'm sorry, I can't hear you. Can you grab the mic from?
Okay.
So John was just saying it was a necessary evil, right? But I would also just say, just as a reminder, right, like if you look at Kubernetes as a community, especially the storage SIG, we're a very fast moving SIG, you know, in contrast to often a lot of other open source projects, right? So I'd say that just as a reminder. And then also incentives are important. And I think all the right incentives are there, right? So yes, everyone acknowledges that this is like a prelim initial interface. It's not trying to bite off more than it can chew, and we got to let it bake. And what Mike said about like how we handle API, you know, going from alpha to beta to, you know, GA, that like those are all different sort of constraints on the system that help us deliver stuff that is future proof. But like the COs all have the right incentives, and the storage providers all have the right incentives, right? Because it's what's going on right now is painful. So I think it's going to have a good outcome.
Yeah. All right, let's jump into implementation. We've got about 40 minutes left in this time box. So I sent out this document to the storage SIG. The purpose of it is to capture everything that we're going to have to do on the Kubernetes side of things to enable CSI. Background here is details about CSI. First, let's go over the goals really quickly. The goal is to define Kubernetes API for interacting with an arbitrary third-party CSI volume driver. Define a mechanism by which a Kubernetes master and node component will securely communicate with an arbitrary third-party CSI volume driver. Define a mechanism by which Kubernetes master and node components will discover and register an arbitrary third-party CSI volume driver. And then recommend packaging requirements for Kubernetes compatible third-party CSI volume drivers. The operative word here is recommend. We are going to offer a mechanism by which Kubernetes users are going to be able to use CSI. How it is deployed, we're going to suggest, and we're going to help provide packages that will make it easy to deploy. But we're not going to dictate that or prescribe it, so that we leave this implementation open enough that folks can implement and deploy however they please, storage vendors. And finally, recommend a deployment process. So both deployment and packaging are recommendations, not prescriptions. Finally, non-goal is replacing Flex volumes. I think at this point, Flex volume has lots of implementations in production in the wild, and we can't break that anymore. We need to make sure that we have enough end-to-end tests to ensure that Flex remains stable, and there are no plans to deprecate it anytime soon. So if you're using it, then you can continue to use it. But if you want to use CSI, you can. They'll both coexist.
Are we planning on implementing those test shared environments? You know, and I've been talking about that with cloud team about adding them to home charts, but ongoing right now, really the end-to-end testing exists in Google.
A shared environment as in across cluster orchestration systems?
Yes, so we have a way of testing.
For CSI, that would be the goal.
Okay.
It'll require, I think, significant effort to actually set that up.
Yeah, we can talk about that if we want to, but we had a meeting with the CMCF cross-cloud testing team.
Okay.
And they had resources, and they had some framework that could help.
Cool.
This is an area where vendors can really help too.
Yeah, I was just commenting that we had a meeting, Aaron and I, with the CNCF cross-cloud testing team, and they have a package and a framework that can help test across, I think, 4 different clouds at this point. So we could look at that as part of this to try to leverage those resources for now.
Yeah. I mean, as far as Kubernetes is concerned, I want to make sure that we have end-to-end tests that are testing the interfaces for both Flex and CSI, so that we're confident in the interfaces and don't cause regressions in them. I would also like to see a handful of actual volume plugins being tested, not just stubs, to ensure that they're doing what we think they're doing. Beyond that, we would have CMCF level testing independent of Kubernetes. And then it would be up to volume plugin vendors to ensure that they are testing their volume plugins against the environments that they care to deploy against.
So why, okay, so granted, there are implementations of Flex Volume, but we do have a process to deprecate things over time.
Yes.
I just worry that it's, you know, part of the feedback that I think John was sharing as well is like, it's confusing, right? We have all these interfaces, like which one do they build to? And while I'm routinely surprised at how confused people are about this. So keeping it around, I think, is going to perpetuate that confusion. Like, how do we manage that?
Yeah, it's a good question. Realistically, our deprecation policy is 1 year or Kubernetes 2.0. So we don't have to make the decision now. I think let's wait for CSI to come out and see if folks are starting to flip over from Flex to CSI, or people who have created CSI volume plugin or volume drivers want to stay there. And we can use that as a signal to make the decision. We don't need to make it yet.
Do we have the document though? I mean, so we have this internally, which is kind of like the cheat sheet of what the heck do all these words mean? For some reason, Flex is one of the most often used, you know, keywords in computer engineering. There's so many products that are called Flex, you know, from Macromedia, you know, Visual Studio things to, I guess, our storage volume. Do we have a document just anywhere on GitHub that says, like, you know, the entry plugins, Flex, CSI, that just outlines this for people who are new? No, but not, the design doc I think is too much. I'm thinking like just sort of like an onboard, you know.
Because I know I read it when about 6 or 8 months ago. So there is something that describes in-tree, out-of-tree, and Flex.
Yeah. And CSI also, and which one to use. I kind of, yeah, I kind of feel like we need that, the sort of which one to use for new users.
So we have an onboarding. Did the onboarding stuff?
I don't think it did. But that's yeah, that's a good topic for onboarding. I think in general our documentation can be better, and you know, if I think one of the things we're hearing loud and clear in this meeting is that there is confusion, and we can do a better job communicating what these things are and helping folks.
Can someone just volunteer to take ownership? Thank you. Cool.
Thank you.
Yeah. So I was going to comment that this thing about 5 options, which one should you take? Right now, the only way to get it is Slack. Slack, you ask people like, what the heck is this thing and that thing, and the right people respond very fast. You just have to put that in the table.
Doc.
So we have a landing page from our last face-to-face, right? Like we talked
Yes.
about putting that together with our, does that
It
exist?
exists. It's in the community repo. There's a SIG storage section. Steve created it. We can extend that.
Yeah. Because here's the thing, though. I mean, the issue is that people that are confused about this stuff, like, want to come into this place to read. Just, it's kind of bad on them, but like, you know, just I think part of the thing is if you have something simple, then it's easy for that simple thing to get diffused consistently. But if it's kind of murky, there's a couple of trade-offs, then the way it gets diffused and shared, everyone gets it.
I think there's a pretty simple message though, which is in-tree plugins are gone. You can't do them anymore. We want everyone eventually to get to CSI. It's not ready yet. If you really want it now, use Flex. Here's some links. I think that message is pretty straightforward. We're pretty unified by it. It should probably be on like the SIG community storage page. You know, we can talk more about it in detail, but I don't think it's going to be that much worse.
I agree that's simple, but that's why I was kind of saying, that's why I was like, oh, we have no plans to deprecate Flex. I think what we're really saying is we're in a trial period right now, and we don't want to do any knee-jerk reactions where we push Flex out. So maybe we could communicate that a little bit, or to sort of more support what Mike was saying.
Yeah, I think the key takeaway is let's improve documentation or onboarding docs. We have a SIG storage community page, and let's get a crisp, clear message out, similar to what Michael summarized.
Make that landing page like the top result.
Google.
Actually, I have something to say.
Yes.
Side note, there is other projects that are going on in the community right now that are very similar to what you all are discussing right now. SIG Docs is putting together user persona guides. So it's kind of like pick your game character. For instance, one of them is code contributor upstream. Another is developer. Much of which you're talking about is developer, and each one of those ideally will have a SIG developer guide. So this is, I think, across SIGs, the problem of how to onboard both new developers and new contributors to your project. So definitely look out for that kind of stuff in the next, I'd say, 1 to 2 months. But if you have anything that you're already using for contributor/developer guides, let me know so I can we're compiling all of this information right now. And it could definitely help. I mean, I think onboarding in general to Kubernetes, not even just SIG storage, is, an issue. But yeah, sorry.
Cool, that helps.
Is there going to be a migration path at all, or recommended migration volume to CSI? Or really anything, but I'm particularly interested in flex volume.
What were you thinking about when you?
Just any recommendations or anything to go from a vendor that provides a flex volume implementation to moving to a CSI driver.
So our first CSI plugin could be a flex bridge, right? Like that would be the lowest hanging fruit.
Yeah.
And then having the flex bridge would kind of show people here's how you get flex into CSI. You just use this bridge.
Yeah.
So without designing it here, I think there has to be, and so there will be. There has to be a guide from going from one to the other.
Even if it's strictly docs.
Yes.
Yeah. I think that'll be part of the stability work that happens. Right now, we're focused on getting an alpha implementation out the door.
You could write it.
All right, we have 30 minutes left. I want to jump into the design. Very simply put, CSI volume plugin is going to be a new entry volume plugin. You're familiar with all the existing entry volume plugins, NFS, iSCSI, Flex, of course. And so CSI is going to be identical to those. It's just going to be a new entry volume plugin. And we are going to prescribe only 2 things, basically the communication channels, the mechanism by which Cubelet is going to talk to an arbitrary CSI endpoint, and the way the master is going to talk to an arbitrary CSI endpoint. Everything else is up to plugin vendors to decide how they want to do. We'll have some recommendations on how they should do it, but we're not going to prescribe that. So first thing I want to show you is the volume source. Here we go. So when you interact with Kubernetes today, you interact through the Kubernetes API. You guys are familiar with the existing volume sources for all the existing entry volume plugins. For CSI, we're going to extend the API once again, introduce a new CSI volume source, which will be accessible through persistent volume or direct inline volume reference through the pod. The API is going to contain a driver name indicating which driver you want to call out to, a volume handle string indicating which volume that you actually want to attach to, a optional secret reference to use for attach and mount, and whether it's read-only or not. So pretty similar to the way that the other entry volume plugins are handled today. Then the second part of this is how provisioning happens, create volume and delete volume. That is going to be through the existing storage class mechanism. So you would create a new storage class, and as your provisioner, you would pass it CSI, and that will handle provisioning. So that's the interface facing the user. Next up is the logic on the Kubernetes side. And for that, we have the communication channels. So between Cubelet and CSI is going to be a Unix domain socket. If you look at the CSI spec, yes.
Yeah, I'm sorry, I have a question about the last the CSI volume source you were just showing.
Sure.
So where are the set of opaque parameters
Yeah.
that are specific just to a particular driver? Where
Yes.
those get stored?
Storage class. Yes.
Okay, okay.
So on the for that gets passed through on the create calls, and that's the same storage class interface that we have today. So communication. So let's actually start with the. I'm going to start with a kubelet, which is the mount unmount calls, because this is the simplest part. Kubelet decides that I need to mount this particular CSI driver to a particular path. It generates the path as it does for existing volume plugins today. It's the volume plugin name / pod UID. And it passes that through a Unix domain socket speaking the CSI gRPC interface. It calls node publish volume. And the assumption here is that on the host machine, on the node machine, there is going to be a Unix domain socket that is listening and handling the node publish volume calls. This Unix domain socket is expected to be registered with Cubelet through a generic Unix domain socket registration mechanism, which was developed last quarter for device plugins that are being used for GPUs. We're going to extend that and use it for CSI as well. So that part is fairly straightforward. The more interesting part is, how does the master communicate with an arbitrary CSI volume plugin? One of the challenges here is that you don't want arbitrary third-party code running on your master machines. Ideally, the third-party volume vendor code should be running as a container somewhere on your nodes. But if that is the case, how does the master control plane, when it decides to attach or create a CSI volume, talk to a container that's running somewhere on one of the nodes? So we went through the exercise of thinking about ways we could expose a service from one of the nodes that the master could talk to be able to do create and attach calls. But what we figured out was it was making the system very complicated, especially figuring out how to secure that channel in a consistent way was very challenging, and discovery was a nightmare. So what we did was kind of flip the script and follow the design patterns that Kubernetes already has. Kubernetes doesn't really have components that call out to other parts of the system and tell it what to do. If you look at the way Kubernetes is designed, all parts of Kubernetes watch the Kubernetes API and then figure out what they need to do on their own. So for the external attacher, which Brad and team have worked a lot on, this mechanism looks at, you have some service that is sitting on one of the node machines or external to Kubernetes and monitoring the Kubernetes API, monitoring PVC and PV objects, reacting to them and creating new volumes. So as far as provisioning is concerned, we're going to reuse the existing external provisioner mechanism. So folks who already know how to use that will be able to use it. But you would have some component which is watching the Kubernetes API on behalf of a CSI Flex driver. Once it decides to do the provisioning, it can go ahead and make the CSI specific calls to a sidecar container or wherever the CSI endpoint is, and they can decide how to do the communication between the Kubernetes specific component and the CSI component. And so the next challenge is in doing attach and detach. The way that attach and detach currently exists in the Kubernetes system, it calls out to the volume plugins in tree. And we are not going to be able to do that for CSI. So the proposal is to introduce a new attach volume object The name here is controversial, and this is probably the most controversial aspect of the design. I think we're going to end up calling it volume attachment, so don't get too stuck up on the name. We want to make this a noun. But the idea here is that when a CSI volume needs to be provisioned, a new non-namespaced object is created in the Kubernetes API to indicate that attachment is necessary for this particular volume to this particular node. So if you look at the details of this object, it's similar to existing API objects. You have a spec, just like the pod spec, and a status. And in the spec, you have an attacher, which corresponds to the provisioner that exists for external provisioners. And you have the volume source, which is the volume that needs to be attached. And finally, the node name that it needs to be attached to. Brad, do you have a question? Or?
Yes, kind of. So you made a comment earlier about not wanting to run untrusted code on the master.
Correct.
How concerned with security do we have to be with all the aspects? I mean, if we have untrusted code that's modifying the API object.
So it's a good question. I think the line that I wanted to draw was just note untrusted code on the master. As far as running the actual volume plugin on the nodes, I think you're going to have to give it a significant amount of permissions in order to be able to do mounts on the host machine, in order to be able to drop Unix domain sockets on the host machine. And
it's like if we're doing that, why not just run untrusted code on the master? If you have access to the API object.
So there are implementations like GKE, for example, where you can't do that, where you can't run untrusted third-party code on the master. So that's just a non-starter. But if
it's not necessarily a security issue, it's just a
implement.
We're fenced off.
And the way that it's currently spec'd out, it doesn't prevent you from doing that. So optionally, you could have these components running on the master. The mechanism that you communicate between the CSI components and Kubernetes is the Kubernetes API. So theoretically, you could have the drivers that are handling these calls run on the master if you wanted to. It leaves it open. And this is an out-of-date version of the doc. I don't think I've refreshed it, but.
So another question. So we have external, we have the CSI plugins that are watching these attached and detached objects. I'm assuming there's.
Can you guys use the mic, Brad?
Oh, sorry. So we have the. Does this work?
Is there a button on there?
So we have the CSI objects that are, watching the attach, detach objects and attach and detaching volumes. Is there a Kubernetes piece that's going to be cleaning up after them or making sure that?
So the entry volume plugin component is the one that's going to be creating and deleting these objects. So I was going to go into details, but we can jump directly into that. Let's see here. So the entry volume plugin interface is going to implement the attachable interface in the volume plugin. So it does mount and unmount and attach and detach. So when the entry attach method is called, it's going to go ahead and create this new attach volume API object. If you have an external controller that is monitoring, it sees that a new attach volume object is created and that the attacher name corresponds to that particular controller. So it goes ahead and triggers the attach for that particular volume, and then it updates the status to indicate that it's actually attached. And then when Kubernetes comes along, it now actually has a robust way to be able to know what's attached because it can scan the existing API and say, oh, these are the objects that should be attached. And then when it wants to detach a volume, it's simply going to delete the attach volume object. And Tim was telling me about this on Friday. There is this cool new finalizer interface that we're going to be able to use to ensure that volumes are detached. So what you do is when the attached volume object is created, you specify a finalizer. When the object is deleted, Kubernetes will refuse to delete it until the finalizer removes its name from that finalizer list. And so in this case, the controller that is doing the attach will monitor, and if it sees the delete of an attached volume object, it's going to say, okay, now I need to actually detach this particular volume. It's going to go ahead and do that. Once it completes, it's going to remove the finalizer from the attached volume object. And then Kubernetes is going to come back, and then it's going to trigger a delete again, and then Kubernetes is going to come back and delete that object. Luis?
Yeah, I just wanted to kind of clear something a little bit.
Sure.
That what we're talking about is not the CSI driver from the vendors.
Correct.
I just want to point that out.
Yeah.
That this is all Kubernetes enablement of CSI packages. So just want to point that out. So everything, all the code that's doing all of this is all Kubernetes. Right. Yeah. So I just want to make sure, because the message that we're sending is Kubernetes is doing this, Kubernetes is talking to itself.
Yes.
Right. I just want to point that out. It's not the CSI package from the vendor.
Right. And basically what we want to do is make it so that an arbitrary CSI volume plugin can just be dropped and work on any system. We don't want it to, we don't want folks to have to do extra work to plug into Kubernetes. And so we're going to do as much of the heavy lifting as possible. And that kind of actually is a good segue into the recommended mechanism for deploying CSI on Kubernetes.
Wait, one more question.
Yes.
Have you ran this through like an HA evaluation?
Yeah.
Like, can we have multiple attachers running at once?
Absolutely. So we can talk about that now. So there are actually two different mechanisms that we've come up with to deploy as suggested mechanisms. I'm going to actually lean towards the second one. That's the one that Tim suggested after I met with him. But this diagram, the first recommendation is actually makes it very easy to understand what's going on. So in this case, what you could do is deploy a daemon set which contains two containers. One container would be your CSI volume plugin. It would expose a Unix domain socket per the CSI spec that implements the gRPC CSI interface. Then it would have a sidecar helper container, which is the Kubernetes specific container. This is a container that our team would work on and provide to you. And it would do three things. One is act as a proxy between the kubelet and the volume driver container. And it does that through the Unix domain socket that gets dropped onto the host machine, and Cubelet talks through that Unix domain socket through to the CSI volume driver. And the second thing it does is serve as a controller for attach and provisioner. So a provisioner and an attacher, meaning it monitors the Kubernetes API. And when it realizes that it needs to provision a new volume or it needs to attach a volume, it is going to issue the appropriate calls against the CSI volume driver container, and then write back the responses to the API accordingly. So the heavy lifting in this case is all done by that Kubernetes helper container. Now, the way that I've diagrammed it here, you would have this daemon set pod running on every single node, and you have the, you're going to have n number of nodes. You're going to have n instances that are fighting to be the attacher and fighting to be the provisioner. And so we could use a leader election protocol inside that container to decide which one will take precedence or take leadership. And then if any one of them goes down, you could use a leader election to figure out which one will take over. Now, this particular deployment favors HA, meaning if any one of your external provisioners goes down, another one can pick it up, but it actually has a very big footprint because you have the external provisioner running inside every single daemon set, the external provisioner and attacher. So another proposal is to actually split your deployment into two separate pieces, where the daemon set only acts as a proxy between the kubelet and the CSI volume driver for the mount and unmount calls. And then you deploy a separate service for your attacher and provisioner. And in that way, you're not wasting resources on every single machine deploying an attacher and provisioner unnecessarily.
What if you don't have enough resources at all? What's the prioritization of
Yeah, that was a good question. I think somebody over here was asking earlier about infrastructure containers versus non-infrastructure containers, and Michael had a good answer for that. Michael, do you want to take that?
Sure. So actually, it's a long
Wow, it's like Tim's voice is not just in my head, it's in all of our heads now. This is a longer conversation. It really depends on how deep you want to go. So Kubernetes has...
We need to repeat the question.
Sure. So please repeat the question.
I was asking what if, either this helper pod, that works as a proxy or else a daemon set pod, what if it can't be scheduled on any of the nodes? How does that prioritization work for infrastructure type containers?
So right now, you'll find that Kubernetes is undergoing a lot of analysis in this area for very many different dimensions. We could literally talk about this for hours. You'll see that in the scheduling SIG, there is a whole world of work going on under prioritization so that you can start prioritizing pods. There's also work that's been going on in the node SIG for having things working in the kubesys namespace, which is a namespace that's associated with items and containers that are, as I said earlier, there to keep Kubernetes up and running. On top of that, there's also work going on with node allocatable. Just out of curiosity, how many people in the room are familiar with node allocatable? So a lot of these items are trying to figure out how do we deal with the question that you just asked, which is we want to run everything all over the place, both A, to keep Kubernetes up and running, and then B, to, because we don't want to think about space and we don't want to think about sizing our application or our infrastructure for Kubernetes. It works great when you've got infinite resources. It doesn't work great when you start having to want to pack too many things in the node. So there are tools that Kubernetes has available, and it depends again on how big the footprint of these daemons are. And it also depends on what you want to do. We're going to be probably having to explore as we go how we're going to want to prioritize each one of these items and say, is this item as high a priority as, let's say, the kubelet, or is this one, something that is seen as lower priority, and how this is going to work in the storage SIG. I expect that once all the code is written, figuring out how we want to allocate and schedule the resources is going to become another piece of the work that we have to do. I know it's not really an answer exactly how, but I'm just letting you know that there's a lot of tools that are being put in place in 1.9 and 1.10 that we can bring to bear to solve this question as we learn more about it.
Okay, thanks.
So what are the expectations from a productization question? That extra container is now in the critical path of the communication for the actual vendor code to run.
Yep.
And so people follow their own procedures about upgrading and things. And what's the expectation of that other container?
I don't, sorry.
Go ahead.
I don't think these extra containers should be in the path of communications, should they? In the daemon set case, I would take objection to the drawing. I think the Kubernetes to CSI helper merely sets up the plumbing, and Cubelet at that point speaks CSI directly to the CSI driver. Why can't it just plug the left hand into the right hand and let them go?
Yep, that works too. But I think this raises a bigger question of there are going to be components here that we are going to provide that you're potentially going to depend on. I think that'll be a good question for the release engineering section that Brad has scheduled. I think that question is going to come up with external provisioners and all these things.
Jesus, push it all on.
But if anything, this is a strength of the model in that the vendor can test their driver and they can revision their Kubernetes deployment without revisioning their driver, right? They can run all their battery of tests against the driver container itself and be confident that that works. And then they can release updates to the helper logic without actually revalidating their driver, as opposed to something like a library. So I think that's pretty cool.
And you could potentially cut all of these Kubernetes specific components out and take your destiny into your own hands and do it all by yourself. That this is completely pluggable. Any other questions?
Is it possible to get the mic closer to you?
Yes. Is that better?
Yeah.
Sorry. So next is just the timeline for this. We have a crack team of developers who are going to be working very closely. Louis in the back, Vlad over here, Chakri, who is not currently available. There he is. And Brad Childs, of course, and myself. So we're hoping to drive this design into implementation for Q4 for 1.9. The biggest hurdles that we have at this point are API reviews, getting the getting the new attached volume API approved. Once we have that done, I think that'll be the biggest external blockers that we have, and the rest of it, our destiny is in our own hands and how fast we can implement this.
So did I just hear right? Shooting for alpha in 1.9?
Correct.
Who's the first guinea pig for this? The driver, the person
That is
who's
a good question, and I'm looking at Clint. Yeah, we've got 5 minutes here, or do you want to just use the second slot to kick that off? Maybe you could give a quick 5 minutes, and then we can spill over to the next one. Okay. So yeah, this is a good segue into the volume plugin vendor side of things, and I'll hand it off to Clint for that.
Before we start the next session, we have some time to like small groups talk about like plans and stuff like that. But I don't see that on the board.
That's a good question. So what were you thinking? Like break off into smaller groups for just generic just networking or something?
I'm just going to repeat the question for the people online. I was just asking that on the schedule right now, we don't have a kind of a small groups and talk about, planning and how the project's going to actually get done. So I was just wondering if there was some time that we could schedule for that.
So technically we have an hour empty slot today.
Okay.
I'm guessing that with the spillover, it's probably going to shrink down to 30 minutes or less. Maybe we can use that as an opportunity at the end of the day to just group.
Yeah, that would be great.
Everybody wants to talk about everything.
That's what I was thinking.
Break into small groups too, it'll be impossible.
Yeah.
Yeah, if we do do a small group, then we'll definitely send out minutes so everybody's online. Yes.
So we could save that for the end of the day. Since we have that empty slot, whatever time is remaining, folks can break into smaller groups. And, okay.
That's fine. Thank you. I appreciate it.
Sounds good.
How do I switch it to, do I just go to my name?
Yeah.
Good, cool. All right, so 5 minutes. So the update here is talking about the storage company side of it, like who's the guinea pig. So Dell Technologies and the code team has been working on it for the last, I'd say 5 months since the spec was in kind of early draft. So we've been building a ton of like validation tools and testing around the draft. There's a couple guys on my team that have been doing this, so feel free to engage them through Slack if you're interested in participating. And we're actually looking for everybody to come help and play a part in it. This is a summary slide, so the deck we'll put in the notes. But this is a summary slide that talks about the different things that we've done so far with CSI from a plugin implementation side. So first of all, a ton of validation and discussion in GitHub. So if you look at the issues, like we've taken the spec and we've actually like practically applied it. And we've actually successfully done it across 12 different storage platforms so far. So EBS, Ceph, all the major platforms that are typically in Kubernetes, they've all been validated against the plugin side of the specification. So we're pretty confident with where it is right now that it's actually going to work. There's a library to point you guys to. So if you're thinking about building the plugins, there's a Go CSI library that we currently have under our org. This has a ton of work, which is immediately like relevant to the CSI project. So as the spec goes through implementation on the plugin side, we've got tools for like a CSC client. So it would be a client that you can actually just launch as a process that can test your plugin and do all the basic calls. That repo also has a lot of CI testing in it. So it's got a Travis file. And so it kicks off like a CI testing with a testing framework to validate the spec on the plugin side. So the Go CSI repo is somewhere to point you guys to if you're interested in like figuring out that plugin side of making it easier to actually implement these. We've also tried to keep like a lot of work we've done like native to the specification. So we don't want to add like immediately on top of the spec a ton of like value adds and things that move it away from the specification. Like the first layer that we've really built is Go CSI, which should be relevant to everything and anyone. And then the next thing we've done is we've actually built native Go plugins on top of this framework essentially. So the next thing listed here are 3 different drivers that we've introduced, which are completely native CSI drivers. The first one being the VFS, which is like a mocking driver, which does local file system mounting. So it can run on OS X, it can run on anything else. It uses like loopbacks and it uses bind mounting to actually fully simulate a plugin. So VFS is a cool one to check out as a example plugin. NFS as well, and then Block Devices provides access to like the dev devices to use as volume plugins. And then the other thing to focus on is the containerization work. So one of the key requirements, or one of the things we've talked about for a while, is how do I actually containerize all the dependencies and requirements for the plugins to be successful? We've done a ton of this with all those plugins already. So S3FS is an example. I have a link for it here. But all the platforms that we said are supported, we've actually done all the containerization work already to build the containers that make them successfully work. And then aside from that, we've actually got a Rexray release. You guys have probably heard of that. That's our orchestration tool. That actually leverages all these key components and it packages them together. So if you're looking at like a project which can help you like build a plugin and actually get it packaged out and supported and shipped, Rexray really wraps all that stuff together and makes it super easy to actually like push that stuff out. So that's a summary slide that talks about it. Any questions about that? Overall, our experience with implementing the Go plugins, like by way of gRPC, has been excellent. We were proponents of the lib storage project. You guys probably heard about that. We're in the midst of kind of a massive transition over to completely native Go CSI support or CSI support. I think that using gRPC and defining the interface like in the middle, and then having our implementations on the CO side and the storage provider side has actually worked very well. So we're very excited to see everybody still at the table like working together on it. I've got other slides in here, so if you guys are interested in like examples of all this stuff, you can run through the deck after this, or you can ask us any questions. So any questions, or you guys want to see anything specific? Did I answer the question like who's the first guinea pig? Yeah, has anybody else started writing a plugin? Where are you from?
John, from NetApp.
Okay, from NetApp. Okay, how's that been? Do you have any comments or feedback you want to provide for being involved?
No, I've been going to meetings, but yeah, it's going awesome.
Okay.
Also forecast of when you might have that ready for evaluation or use. It's going to be a while.
Yeah. So for the people on the call, there's 2 guinea pigs so far. It's Dell Technologies and NetApp have been working with the plugin.
You guys already have some.
Yeah.
The API itself is fairly easy. Figuring out some of the mechanics, some of the service.
Yeah, I think the mechanics, I think one of the big things we've looked at as well is the idempotency of it, because typically the drivers really haven't done it the right way through the Docker volume interface. So getting idempotency on top of all the storage platforms has been one of the bigger challenges, which I think everybody will experience as they approach it.
Question then maybe Saad as well. So when CSI goes alpha 1.9 and we have the Rexray, let's say EBS support, how do you choose between this one and the native, the EBS plugin provision when I'm setting up Kubernetes?
So repeating the question, when we get to that transitional period of having AWS EBS volume plugin as it is today, and then when the Rexray or the Go the CSI plugin that supports EBS comes out, how do you decide on the two? That's a question. Do you want to?
It's a good question. I think somebody was talking about proliferation of choices and how it's bad. It's going to get worse. You're going to have CSI volume plugins that are native. You're going to have CSI volume plugins that are implemented via RexRay. You're going to have entry volume plugins. You're going to have flex volume drivers. And in the end, it's the responsibility of the driver or the cluster administrator to decide what's best, weigh the trade-offs, and decide what's best for them.
Yes, my question wasn't how do I choose which one to use.
Uh-huh.
My question was controlling which plugin is going to provision an EBS volume. Is that through storage process?
Yeah.
Yes, that mechanism is identical.
CSI, EBS storage process.
Correct. Yep.
Yeah, so the question was how you actually choose the plugin. And I think what Saad defined in this design document was that the plugin driver name, the CSI driver name, is how you specify which one you want to use. The other side of that is like, I think another project that's going to be interesting is getting the Kubernetes, the current drivers, right, out of tree. And so we kind of wrote Go CSI to be that first level, library. That's the helper. The RexRay project has an AWS implementation already. Kubernetes has one slightly different. So we're definitely interested in collaborating on figuring out like how to get the two things together, get the best of each driver, and create a great Go CSI plugin that represents all of the major platforms. So if you guys are interested in participating and actually building the plugins that kind of bring the two things together, or any other number of sources that have the drivers in the ecosystem already, please reach out to us, and we'd love to collaborate on it. Yep.
Yeah, so this is really, really interesting. It seems like I might need to take a quick step back for a second, because it seems like you took a huge leap from just talking about Saad's design for how CSI is going to be implemented within Kubernetes, and then now it looks like you're talking about some CSI plugins that are done, completed, running, working.
Mm-hmm.
Is there more work that's already been done in functional on Saad's design, or is this outside of Kubernetes? And you look for other container orchestrator systems?
So to repeat the question, commenting on the jump, like we just saw the design of Kubernetes, and it's in design phase, no code yet, and then we were just talking about actual implementations of plugins. The plugin implementation, I think, was much easier. Right, there's much less to decide on that side, and architecture-wise, I think less impact. So that stuff was easier and quicker to be done. So I don't know if there was a question there.
And you guys have been implementing against stub servers.
Yeah. In the implementation, so there's one key tool in this Go CSI package. It's CSC. And so CSC is just a sub implementation of the specification. So if you want to do a controller publish, controller unpublish, CSC is that tool that lets you do that test. What that doesn't have, though, is each of the COs is going to have their logic that they build on top of that, even for idempotency and other things. So it doesn't have that in it. And that's really the design document, is that next level of how you actually use those semantics and calls. Got it. Cool.
And actually, I'd like to follow on that, because last week when I kind of started all this, I had that same question. And one of the things that I would like to suggest is that the CNCF is leading the CSI.
Clarification. So CNCF is not leading CSI.
Sorry. Okay.
Yeah.
So, okay, whatever words you want to put on that. Then what I would like to see is that it has a standard model of doing unit tests and client tests, so that CSI writers can go to a certain one page that has the spec and has for the Go, at least Go code writers, that you can just vendor that in and then run your unit tests for your own code. And I would like to have that as part of the spec writer group, whatever that is, to be able to define that.
So Lewis was asking for a common place if you're writing a plugin or even the implementation to go, so you have the spec essentially validated by way of CI testing as it moves forward. I think that's a summary. I think what we talked about a while back is that would be great to have a library in the repo, but that we're going to let the community iterate a little bit, and let's see what kind of libraries come out, and then figure out at a later point when to get that in.
So I think at this point, the spec itself is not even 0.1 yet, because we don't want to we'll call a spec 1.0 until it's ready. But before we call it 1.0, I think one of the requirements is going to be to have a certification tool, which a arbitrary plugin can run against itself to validate itself.
No, I don't mean to have like a wait till that point. I mean, this is already happening, as you can see, right? So we are the community, so we just need to make a repo that does that.
Yeah, we can we can do that tomorrow if you
that's
want.
what I mean.
And that's what this, like what you define
So-
is essentially this Go CSI repo that we created, right? It's that basic framework and harness to make it a little bit easier to wrap the bindings. And then it's also the validation testing using a mock driver, so that as the spec revisions, like it's there. But it's not in the CSI repo, it's in our
Are
board
you
right
are
now.
you asking though about something that can show conformance to prevent fragmentation?
No.
Okay, then what is it? What's the question?
A standard test
I just need the
architecture.
to come
Yeah.
together and create a. Sorry. Yeah, like I said, I just extend. I just would like the community to come together and have one repo where we all work on, where it has libraries that we pull in for Go at least, other languages too. And definitely at least has the protobuf already compiled, so we just take it.
That's already there. If you look
Okay.
in the container storage interface repository, and it has underneath the spec, there's a lib folder which has a compiled version of the protobufs as a Go library. It's a starting point. It's not yet ready to use, but where we can build on top of that.
Then we should get
Yeah.
the team.
And we've got a library in place. Like, so if you want to collaborate, we'd love to have you there. And whenever the time's right, we'll talk about where that ends up
Saad,
going.
can you put a pointer to that repo inside the minutes?
Yes, I can.
Okay, that sounds like a good thing. Also, a pointer to these slides would be great in the minutes too.
We'll do.
So one other thing about not only having a common repo for everybody to contribute to a test harness and a framework and everything else, that'll make development of plugins significantly easier for people to come in, because they'll be able to actually look at the code and figure out what they're supposed to be doing. So that'd be awesome.
Yeah. I think, well, one thing that we're afraid of is having blessed implementations or biasing or that kind of thing. So we shy away from anything like that. But I agree there are common utilities libraries that we can definitely have as part of the CSI repository. And that's kind of the plan.
So Clint, where do you see the future of Go CSI? When it was announced a few months ago, we saw that as like a proof point that the CSI spec is not infeasible. It can be done.
Yeah.
And so now we can write drivers using this tool that verifies that if there was a CO sitting on top of us that adhered to CSI, we are good from like a driver writer's perspective. But then do you think Go CSI will mature into something that integrates into like Swarm or Kubernetes? Is that like the plan?
Its intention is to be like that first layer above the bindings, essentially. And it's intended to validate the spec as it moves forward with actual code. Thank you. So it's in our org today, and we'd love to see it collaborated on. And if there's other CSI libraries out there, we haven't seen any yet, but we'd love to see other ideas that are out there and figure out what the best thing is for the project moving forward. So cool. All right, so the links are in that doc, Mike. So I
I'm
think
going
we're good.
to put the links in there. All right, let's keep it moving. We are 10 minutes over time. Do folks want to take a break or jump right into the next item? Raise your hand if you want to take a break. 2 people? Okay, let's take a 5-minute. We'll meet back at 11:15.